All right, let's dive into databases. We got some excerpts from Introduction to Databases someone sent in.
So that's pretty dense.
Yeah, it is a bit.
Yeah.
But it starts off, actually, by asking a really interesting question.
Okay.
It asks, how has data impacted your life? And, it's not something we think about every day, is it? But data really is everywhere.
True.
Has it ever, changed your mind about something or even tricked you?
Oh, for sure, yeah. I think the thing about data is that, we think about it as just numbers on a screen.
Right.
But it's not just that, right?
Right.
It can be images, it can be audio, it can be text. The textbook actually says that it's really just any way that we describe the world around us.
Yeah, that's a good point.
Yeah.
And that brings us to, I think, a really key distinction, this idea of data versus information.
Okay.
It's not just about collecting raw data, right?
Right.
It's about turning that data into something that's actually useful to us, useful knowledge.
Yeah.
And that's where databases come in, right? Mm-hmm.
That's where databases come in, exactly. The textbook actually gives a really good example about student grades. Like if you just have a list of every student's grades, that's just data, right? Mm-hmm. It doesn't really tell you much. But a database can turn that data into a GPA.
Right.
And now you have information. You can actually learn something about that student's overall performance.
That makes sense.
Yeah.
So how does a database actually work? What are, the nuts and bolts of this whole system?
Well, imagine a giant spreadsheet with rows and columns, right?
Yeah.
Like a massive spreadsheet. That's essentially what a database table is.
Okay.
So each row would represent a specific thing. So in this case, let's say a student, and then each column would hold a specific piece of information about that student.
Yep.
So their name, their email address, their major, that sort of thing.
Gotcha.
Yeah.
So we have all these tables that are just filled with data, essentially. But I think the real magic comes in when we connect them.
Right, exactly. The relationships between the tables, that's where it gets really interesting.
Yeah.
That's where you start to see the bigger picture. It's like connecting the dots,
Yeah.
So, for example, you could link the students table to, let's say, a classes table.
Right.
And then you could see who is enrolled in which course.
Mm-hmm. That's cool. So it's like a giant web of information.
Yeah.
All interconnected.
It's a big network.
Yeah. Speaking of connections,
Yeah.
let's rewind a little bit and trace the evolution of databases. I'm always fascinated by how these things came to be.
Yeah, it's a long history.
Right.
But an interesting one. I mean, before databases, imagine trying to manage all this information just stored in separate files.
Oh my gosh.
Right. It was a nightmare.
That sounds awful.
Just trying to connect any pieces of data, just trying to find anything. It was so difficult.
It's funny. They call it the pre-database era. It sounds kind of dark.
Yeah.
So how did we get from that chaos to what we have today?
Well, in the 1970s, there was what some might call a relational revolution.
Okay.
This new model came along, and this model, it organized data into related tables, which made it so much easier to access the data, to analyze the data. It was a total game changer.
I bet.
Yeah. You work with data every day. Can you imagine life without it?
Oh, gosh, no. No, absolutely not.
Yeah. But it didn't stop there, right?
Right.
The textbook mentions object-oriented databases, too.
Yeah, that was another thing that I wanted to ask about. So it seemed like they were trying to apply these ideas from, programming to databases.
Yeah, exactly. It was kind of an interesting experiment.
Did it work out?
But it never really gained widespread adoption.
Oh, why is that?
I think it was kind of like trying to fit a square peg into a round hole.
Oh, okay.
It just wasn't the right fit.
So the relational model kind of reigned supreme.
For a while.
Yeah. But as technology advanced, I'm guessing databases had to evolve too, right?
Oh, absolutely. You think about the explosion of data in the digital age.
Yeah.
We needed a way to handle massive amounts of information, and that's where data warehousing came in.
Okay.
These giant data storehouses.
Wow.
They helped businesses analyze all this information to make better decisions. Imagine a company like Amazon.
Right.
They have to track millions of products.
Oh, God.
Millions of customer purchases. They need a way to manage all of that data and make sense of it.
That's crazy.
Yeah. So data warehousing was a big step.
Okay, that makes sense.
Yeah.
So that's data warehousing. But then, the internet came along.
Right.
Mobile devices.
Exactly.
Suddenly, everybody's connected.
Yeah.
How did that impact databases?
Well, it was another major shift, because suddenly databases weren't just for big companies anymore. Anybody with a computer, right? Anybody with a phone could access information, could interact with databases.
Yeah.
Think about social media platforms.
Right.
They rely on databases to connect millions of users and store their posts and photos and all that.
Wow.
So it really democratized access to information in a lot of ways.
Yeah, that's a good point. That's a good point. So we've gone from like these clunky file systems to these incredible interconnected systems that are powering so much of our lives.
It's amazing, isn't it?
Yeah.
And remember where you've come.
So what's next? Where is this evolution heading?
Well, the textbook hints at some pretty exciting possibilities.
Okay.
We're already seeing the rise of big data and NoSQL databases.
Okay, hold on. We're getting into like new territory here, right?
Yeah, a little bit of
big data, NoSQL. Can you break those down for us? What are those?
Okay, so imagine all the data generated by social media.
Yeah.
All the posts, the images, the videos, the comments, everything.
Yeah.
That's big data. Data sets that are so large and complex that traditional databases just can't handle them.
Wow. So how do you even begin to manage something that massive?
That's where NoSQL comes in.
Okay.
Because unlike relational databases, which organize data in tables with strict rules, NoSQL databases are more flexible. It's a different way to store and process data that doesn't fit neatly into rows and columns.
Gotcha. So NoSQL is kind of like a different approach
Yeah.
designed for this age of big data.
Exactly.
Okay. Does that mean that traditional relational databases are becoming obsolete?
Not necessarily.
Okay.
Relational databases are still incredibly valuable, especially for structured data.
Okay.
But NoSQL is definitely shaking things up.
Yeah, it sounds like it.
It's offering a powerful way to manage all this unstructured data that's coming at us.
This is getting really interesting.
Yeah.
So we've got all these different types of databases evolving to handle all these different types of data. But why should we care?
Well, because databases are everywhere.
I mean, I get it. They're important.
Yeah, they really are.
But, why should we as, individuals care?
I mean, think about it. They're behind the scenes powering everything.
Right.
Our online shopping experiences, our social media feeds.
Okay, yeah.
All of it.
I guess you're right. You're right.
Understanding how databases work, it gives us a deeper understanding of how the world works.
Yeah, that's a good point. So it's not about just, being a tech expert.
Right.
It's about being an informed citizen.
It's about data literacy, which is becoming more and more important.
It really is.
Yeah.
Wow. This has been incredible. We've gone from mountains of messy files to these sophisticated systems that, power our world.
It's a pretty amazing journey.
Yeah, it really is. But there's so much more to explore, right?
Oh, yeah. We're just scratching the surface.
So we'll continue our deep dive into databases next time. Until then, keep those data exploration skills sharp.
Absolutely. See you then.